All right, so this video is specifically for those doing step D here with an X500. And I neglected to add something in my last attempt at recording this video, so I'm re-recording it. So hopefully we get everything this time. But if you have an X500 with an H743 flight controller, this is the video you want to follow for applying your notch filter. Okay, so the ability we have with the X500s and the H743 flight controllers is to do our notch filter application via ESC telemetry. Okay, instead of having to use a throttle-based notch, which is fine but less precise, we can actually use a notch filter based on, excuse me, RPM of our ESCs. Okay, our ESCs should have been flashed with the BlueJ firmware last semester in the maintenance class, or whenever you took the class, which allows them to then communicate back to the flight controller the RPM of the motors in real time, basically. And then the flight controller can apply the notch filter more accurately to that frequency. Okay, so we have a page here that goes over different types of notch filters, right? We have different modes we can set. The one we're using here is number 3, okay? And I labeled this incorrectly. I should have C number 4 on this link. Sorry about that. So we're looking at number 4 here, INS harmonic notch mode, number 3, which is labeled number 4, okay? Basically, this is saying, hey, we're going to choose this one. We're using ESC telemetry to be able to track the frequency and apply the notch to that frequency, okay? The other link here is the specific steps for setting up this notch. Okay. Before we jump in that, there's the thing I forgot. Okay, let's go into Mission Planner and talk about this for a second. So if you go and you connect to your aircraft and go to the config and full parameter list, okay, we need to make sure that the bidirectional D-shot function on our flight controllers is essentially turned on. Okay, you all should have flashed the correct firmware for bidirectional D-shot when you flashed your flight controller in the maintenance class, but we never really used the bidirectional part of it until this point. Okay, so bidirectional D-shot means the commands to the ESC go from the flight controller to the ESC to tell it how fast to go, the motor how fast to go, and then the ESC can send back some data and tell the flight controller, hey, my RPM of my motor is this, temperature of motor is this. There's different things it can show. Okay, let me show you that to you real quick, actually, just for an illustration. If we review a log where I have this turned on, okay, and we go to the ESC section, which won't appear unless you have this turned on. Okay, this is one way to tell. You can see 0, 1, 2, 3. These are my 4 motors, and I can look at like the RPM of the motor in real time from the ESC. Okay, if I didn't have this bidirectional D-shot ability, I would not be able to see this. Okay, I could tell what the flight controller told the ESC to do, but I wouldn't have any feedback about what the ESC was actually doing. Okay, so that's what we're turning on. Okay, let's go over here to see config again, to our parameter list. Okay, so we're going to search for servo BLH. I'll move my mouse a little bit. Servo BLH. You get a bunch of parameters like this. Okay, so some of these may be on or may not be on for you, depends on what firmware you're on and that kind of thing. I'm actually on a different flight controller than an H743, so I'm just kind of showing you this demonstration here for what you'd want to have on. All right, so BLH auto should be enabled. Okay, that's right from last semester. That allows you to talk to the ESCs through the flight controller, and that should just be turned on. Okay, the BLH BD mask. Okay, this is what we want to make sure we turn on if it's not already on. Mask of channels which support bidirectional D-shot. Okay, so if your ESCs have the BlueJ firmware, which they should from maintenance class, okay, allows support bidirectional D-shot, allowing fast RPM telemetry values to be returned for the harmonic notch. That's exactly what we're doing. So we click on this, little pop-up's going to happen here, and we have our channels we can select 1, 2, 3, and 4. That's all we need because those are our motor channels. So when you select those, it changes the value here. Okay, so just select 1, 2, 3, and 4. We should get 15. Okay, and we write the parameters. Okay, that's saved. Good. All right. I'm still trying to figure out why this one doesn't save when we save it in the setup, but you might as well turn it on. Okay. In this class in the setup, I think we're using D-Shot 600, so we'll just set this to 6. I think it's turned on automatically, but I'm not sure why the parameter doesn't update. So we'll set that to 6, make sure that's working. Okay. The other ones here you don't really need to worry about at all. Leave those alone. Okay. But the main one here to make sure this is working is the BD mask, the bidirectional D-Shot mask. Okay, so once you have that set up, then we're good to go. We can go back to this page and start setting up our harmonic notch setup. If you'd like to double check after you set these parameters, you can always refresh and make sure they saved. Okay, looks like it actually didn't save. Let's see, my BD mask, where did it go? I think it's not saving on this flight controller because I don't have a flight controller that is set up like yours is. Okay, sorry about that. Let's see here. Disabled it, debug. That's interesting. It refreshed and didn't give me the parameters I was looking for. How strange. Oops. And that doesn't have the bidirectional D-shot mask because I'm not running a bidirectional flight controller. Okay, but let's not worry too much about that. What you saw on the last screen was appropriate. Unfortunately, it's refreshing to a different option here than what I was hoping. Okay, but we'll go into this setup now that you have your BD mask turned on. Okay, and you want to make sure if you want to double check and test, for certain, then you can go do a flight and again pull up the log like I did here. Once you have a log, you can review it here and make sure you see the ESC data in the log. Okay, if it's not in the log, that means it's not turned on or it's not set up correctly. But that's a good way to check and make sure you set up those servo BLH parameters correctly, is to see the ESC data showing up in the log. Okay. So the next step is to set up our telemetry-based notch. All right, we're going to need a couple different things here. These are all going to be under the INS underscore harmonic notch parameter. Okay. We're not going to use any of the HNTC2 parameters because that would be a second harmonic notch. We're just using one. So all the parameters that end with a 2, don't worry about those. Okay. The first thing we need to do is enable the harmonic notch. I don't know why it's not first in the list, but that's okay. INS harmonic notch enable is the first parameter we need to set. So let's go into our parameter list again. INS HNTCH. Okay. And we see it's disabled. So we're going to go ahead and hit 1 and enable that. Right params. Okay. It saved that, but we need to refresh our parameters so we can see the rest of the harmonic notch parameters. Okay, there we go. Now they're all showing up because we enabled them. Okay. And now we need basically a couple other things. We need a reference, okay, a mode, a frequency, and a bandwidth. Okay, so reference we're going to set to 1. INS harmonic notch reference. It's already set to 1 here for me. But if we see here for RPM and ESC telemetry based tracking, this parameter is set to 1 to enable the harmonic notch filter using the RPM sensor or ESC telemetry set to measure rotor speeds. Basically, we're turning on the reference for the harmonic notch to follow the RPM from our ESCs that they're reporting back to the flight controller. So that's fine right there. Okay. INS harmonic notch mode set to 3 to select ESC telemetry. Okay, so mode here is set to 3, perfect, to choose ESC telemetry. Okay, so make sure you set that to 3. Okay, so we've done reference and mode, excuse me, the frequency and bandwidth. Okay, frequency we can actually grab just from our batch sampling earlier. Okay, so when we do a batch sample here and we get these graphs look like this, you'll have a frequency where the peak kind of starts at. It's around 100 hertz typically for these aircraft, but you want to look at that on yours and see where those peaks are at pre-filter. Okay. And that will be your hover frequency. So you can set this a little bit below the hover frequency. Honestly, you can probably leave it at the default. Okay, if you look here, the frequency is set to 80 by default, and that's a pretty good value. You don't want to go too low with the value because it can cause big lag or delay in the control loop, which will make your aircraft fly horribly or not fly at all. Okay, but if we see over here, it says, let's see, the frequency you set it at is the center frequency for static notches. We don't have that. The center frequency for throttle-based notches, we don't have that. And the minimum limit of the center frequency variation for all other notch types. That is what we have. Okay, so other notch types is what we're using, an ESC-based notch. So basically it's saying that the notch filter won't move below 80 hertz if we set this to 80. Okay, that's the minimum it can do. It'll go up higher, but it won't go down any lower, and that should be fine. Okay, so that's our frequency there, and then the bandwidth, or BW, is half of whatever the frequency is. And so if we set our frequency to 80, the bandwidth is set to 40, that's what we want to do there. Okay. Once we've set all those up, we're basically, done with the setup. There's a couple things I'm going to talk about down here. Okay. But if we just set it up as is right here, okay, then down here below it says checking harmonic notch effectiveness. Basically, once it's set up, you go fly it again. Okay, do a little fly around circles and stuff for a couple minutes. And then you're going to go and take another sample with the IMU batch sampler like we did in this earlier step. Okay. And make sure the noise is actually filtered. So make sure the peaks disappear, okay, or become much smaller in amplitude like we see here. The scale is much different between the two of these, okay? So that's how you would evaluate it and say, oh, great, it looks like it filtered out the peaks. There's not a lot of noise in there anymore. Bingo, we're set, okay? If you want to do anything else beyond that, you sure can. One thing that's kind of interesting is the dynamic harmonics, okay? So by default, the harmonic notch based on ESCs will average the individual motor frequencies and then apply the notch to the average and then add other harmonic notches, okay? Harmonics are basically multiples of the original frequency. So if it's 100 hertz, then the first harmonic would be at 200 hertz, so on and so forth as you multiply the original by 2 and 3 and 4 and 5 times. Okay, and that would probably be fine. Okay, but if you want to, you can configure the harmonics to be first harmonics per motor. So that would give you 4 motors on our quadcopter, 1 for each motor basically. In dynamic flight, this can give much better noise attenuation. Excuse me. We're not going to be flying our quadcopters that dynamically, like we're not doing like flips and tricks and stuff like that in class. But you can try this. If you want, you'll set the INS harmonic notch options to 2. Okay. So here it's set to 0. You can set it to 2. If you click on this little value here, these are all kind of like the special options for the harmonic notch. Double notch, triple notch, enable on all IMUs, updated loop rate, and here's the multi-source. Okay, so multi-source will apply 1 notch per motor. You can try that. It should work just fine. We got plenty of processing power on these flight controllers, but I don't know that it's actually needed per se for this class either. So it's up to you on that one. Okay, next out of that. This center frequency slewing, I wouldn't worry about this at all for the class. You can read through it and dive into a little bit if you want. But at a minimum, you want to do this setup here. Make sure you get all the numbers right, and then evaluate for effectiveness here. Okay. Once that's done, okay, once you've verified the functionality through the logs that the filter is actually working, you have a pre and post filter log that looks like it's improved and filtered the actual noise out. Okay. You can then auto-tune your aircraft and follow that process, which I detailed in a different video. All right. Okay. That should take care of it. Let me know if you have any questions.